All right, so this is the main lesson of scatter plots. We went over the brief introduction, and now we're ready to kind of include more vocabulary and get a little bit more practice. All right, first, vocabulary startup. We want to recall that the graph of a linear equation is a line on the coordinate plane. The slope of the line describes the direction and steepness of the line. So on this coordinate grid, I want you to draw two lines. All right, one line should have a positive slope and one line should have a negative slope. Go ahead and pause, draw, and label in your textbook the positive and negative lines, and then unpause to see if you were correct. All right, let's go. Positive slopes. Well, we always read graphs left to right here, so a positive slope would go up in that direction, P for positive. And then a negative slope would be a line that goes down when we move left to right. That's an N for negative. All right, so we're going to be talking about positive and negative relationships as they relate to scatter plots. All right, we're going to move forward and check out how to construct a scatter plot. Well, you know what? It's just plotting points on a coordinate grid. So let's get some of the vocab here. Data with two variables or pairs of numerical observations are called bivariate data. So this is it, numerical observations here. So the numerical just means they have to have a number involved. A scatterplot shows the relationship between bivariate data graphed as ordered pairs on a coordinate plane. So we showed you some examples of that already, and here are some more examples for us to practice. For example, the bivariate data set year and number of visitors can be displayed as a scatterplot. So because there's two data sets of data here, the years is a number and the number of visitors is also another number. So you can see if those two numbers are related in any substantial relationship. Okay, so let's go with example 1. So construct a scatter plot. Well, if you look at these two variables here, we have the season and then the viewers in millions. So you guys are probably very well aware of the number of seasons for your favorite TV shows. Now you're watching it on Netflix, I'm sure. So my wife just started binging a show that has 8 seasons. I prefer 1 season. That's about as long as I can keep my attention. And what was my favorite? The English Game. It's about how professional soccer started. It's the best, by the way. It's like the best show ever made. You should check it out if you like old school time period pieces, and that are probably kind of boring for you actually, but you should watch it anyway. Anyway, so we're constructing a scatter plot, and as the seasons go on, it looks like what happens to the number of viewers? It looks like as the seasons increase, the viewers decrease. And what we need to realize is, what are we trying to see a relationship? Which one is affecting which one? So I would think that the number of seasons affects the viewers. So seasons is going to be your independent variable, which goes on the x-axis, and viewers goes on the y-axis. Now, this is already all drawn for you, but typically you would have to create this whole thing yourself and decide which variable goes on which axis and which one makes sense. So you just have to talk yourself through that. Which one is affecting which one? Okay, so the number of seasons affects the viewers, and as the seasons increase, the viewers decrease. So, which makes sense. People lose interest. Like me, I would be one of the people who lost after that first season. That big drop here, that's me. I'm one of those people who gave up on it. Okay. Anyway, so you just graph it and you see if there's any sort of relationship. So this is just constructing those scatter plots. So go ahead and construct this. weeks and pounds, and this is the weight of an alligator at various times after hatching. So do you think the weight, the weeks that pass is independent and affects the weight of the alligator? Yeah, I think that should go on the x-axis and the weight would go on the y. So we can see how the weight increases or decreases over time. And if you pause and scatter that, then I'll turn the answer on in a sec. Go ahead and pause. All right, we're back. There you go. If you plotted those, you should have something that looks like this. And you can see as the weeks increase, the weight of the alligator also increases. Let's move on. Now, this is a very important part of the notes, okay? You should probably copy this down or cut and paste it into a document that you can always review. These are the ways we're going to be talking about the different scatter plots. So we can have a positive association. We can have a negative association. All right, and you can see as x increases, as you go left to right, you see that y also increases, all the dots get higher. A negative association shows me that as x increases, as we go left to right, the dots get lower in general, and so y decreases. Here, that was that one that we talked about, the last digit of your phone number and how that relates to your quiz grades. All right, that's no association. Okay, no obvious pattern, they're just kind of randomly scattered on the page. All right, here we have, okay, so if there is a variable association, all right, then we can describe it further and say if that association is linear or nonlinear. So once you've established that there is some sort of association, either positive or negative, then you can say, is that a linear relationship where you can pretty much generalize it as a straight line, or does it have more of a curve or some other interesting pattern that's not linear? So you can have a positive linear or a negative linear association, or you can have a positive nonlinear or a negative nonlinear. All right, there's other shapes as well that the data can have, but those are the general ones that we're going to use to describe our relationships. All right, here's some more vocab. You can analyze the shape of the distribution of a scatter plot to investigate patterns of association. If the distribution shows a positive or negative association, then the distribution can be classified as linear or nonlinear. That's what we just talked about. The scatter plot below shows a positive, nonlinear association. Clusters or outliers can also be identified. Now, a cluster is just a big group of points that are really close together. All right, you can see that here. And then an outlier is something strange that's out of the ordinary, that doesn't follow the pattern of most of the other dots. All right, there's more specific ways to define an outlier, but in general, it's just something that looks out of the ordinary from all the other information, all the other data points. All right, so we're on example 2, and now we're on the part of the lesson where we're going to interpret. All right, we're not going to actually build it, we're going to interpret it. All right, so read these examples carefully and see what is expected of you when a question asks you to interpret a scatter plot. So interpret the scatter plot of the data for the amount of memory in an MP3 player. That used to be what we played music on. And the cost based on the shape of the distribution. Okay, so what are my two variables? The amount of memory, and we're seeing if there's an association between the amount of memory and the cost. All right, well, let's look over here. Do you see as the memory increases, what happens to the height of these dots, the height or the cost here? In general, it looks like the cost is increasing. So how could we describe this association? Well, let's see. If you look back at the page previously, right, we're looking to see if there is a positive or negative association, right? So is x increasing while y increases? Yes. So as the amount of memory increases, the cost increases. Therefore, the scatter plot shows a positive association. You can think of this as a phone as well. You know that if you choose your phone, if you're buying a phone, if you buy the model with more memory, then you have to pay more money. All right, so now we've established that it has a positive association. So now we can move on and decide if it's linear or nonlinear. And they're suggesting that it is linear. It's a little bit hard to see because the dots are fairly spread out at each of the different gigabytes. But we can say that that's fairly linear. We draw one straight line through there to kind of generalize the pattern. All right, other patterns, there appears to be a cluster of data. 1 to 2 gigabytes of memory costs between $30 and $75. There does not appear to be an outlier. Okay, so you can see that this data, they're saying this data right here is a big cluster. That's all this is more close together than most of the other data. Most of the other data is more spread out. Okay, so here you go. Pause and try to describe these two data sets, these two scatter plots, and then unpause and see if you are close. All right, here it is. So B, it looks like a negative linear association. Doesn't look to be any clusters or outliers. Let's see what it describes up here for B. As the time increases, the temperature of the water decreases, so the scatter plot shows a negative association. The data appear to lie close to a line, so the association is linear. There are no clusters or outliers. Cool. And then here we're looking at does the number of the day of the month, or in this 2-week period, does that affect the number of pints sold of ice cream? And it looks like it's kind of just spread out randomly. So there does not appear to be any variable association. So the association is neither linear or nonlinear. There are no clusters or outliers. All right, there we have it. Here's one last example. So construct and interpret a scatter plot of the data. If an association exists, make a conjecture about the number of students that will be enrolled in public school in the year 2015. So this is just adding. My son's playing with toys and he's trying to clean up a little bit, so let's make a little noise. Sorry about that. Anyway, this last part that we're adding in is we're making a conjecture. So if we do see a pattern, some sort of association between the variables, sometimes that can help us predict in the future what's going to happen. And that's the real power of statistics, is in its predictive power. It helps us make plans for the future. So let's look it over. All right, years since 1999. So in 1999 would be 0 years. Then 2000, this would be the year 2000, 2001, 2003, 2004. Okay, so years since 1999. And we're looking at the number of students that are enrolled in public schools. And these are in millions. So when the scatter plot is constructed, we see here, and we can kind of predict, it looks like a positive linear association in general, and it's going up at a fairly steady rate. So if we just continue that steady rate, we can we kind of just eyeball it and look at the year 2015. So how many years would that be away from 1999? 2015, well, if we subtract 2015 minus 1999, that would give us 16 years. So that would be 16 years since 1999. So that would be right here. So where would we predict this line would hit there if we continued this pattern? Right? If we continued that pattern, boom, it hit right about there maybe. So we could predict possibly somewhere between 51 million and 52 million, 51.5 million, if that trend line continued in that direction. All right, let's see what the book has to say about it. All right, as the years increase, the number of students increase, therefore it's a positive association. Okay, the data appears to lie close to a line, so it's linear, and there aren't clusters or outliers. To make a conjecture about the number of students that will be enrolled in the public schools in the year 2015, follow the pattern until the x value is 16. Then find the corresponding y value. All right, so they predict a little lower than us, 51 million students enrolled in public schools. So there you go. So that's how you would use a pattern that you notice on a scatter plot to help you predict the future. All right, here's your chance to try it. Yeah, pretend like you didn't see that. Here's your chance to try it. And this one's a little bit trickier because I don't think it fits. The one that they're making you predict or make a conjecture about doesn't fit on this. Oh, yeah, it does because it goes up by 8. Got it. Okay, so let's just pause, try it, make sure you interpret first. So you're going to describe the relationship between the year and the winning times. All right, the year of the Olympics and then the winning times in this event, the freestyle swim. Okay, ready, set, go. All right, we're back. Looks like a negative association. It looks like it's fairly linear, although it curves a bit, but I'd say it's fairly linear. And then there's no clusters or outliers, and the winning time in 2016 would be about 46.5 seconds. So what I kind of do is I try to stay straight until I hit 2016, and I get right about there, which would be about 46. So I would predict about 46. They said about 46.5. We're in the same ballpark. Just you could even hold a ruler up to your screen or onto your book and kind of try to hit as many dots as you can with one straight line and see where it hits the time frame where you're trying to make a conjecture about. Okay, great job, and hopefully you will excel in this area of scatter plots, interpreting and making conjectures.